So for homework, you guys have 3 free response questions. And if you have not tried these on your own yet, I really, really, really want you to stop this video, stop watching it, and go try these on your own. They're all going to be worth 9 points. And I'm going to give you guys the point breakdown. And so kind of what I want you to do is if you have your work already done, you're going to just kind of like, put +1, +1, and whatever, you'll get a score out of 9. So you're going to, score yourself out of 9. That's very important. I don't want you to just watch my work. Try these on your own, try your best, see what score you can get out of 9. Your goal is honestly to get 6 or better out of 9. But, for the homework, we haven't had too much practice. If you get even 3 or 4, that's a good start. So 6 out of 9 or higher is like your ultimate goal. But for right now, if you've got 3, you're kind of on the right track. So again, pause this video, stop this video, go complete the homework if you haven't, and then we're going to go through the answers and grade it. So for A, I really like problems like A where they give you the answer already. You're just kind of getting there and confirming it. And so they want to see that dy dx is equal to y over 2y minus x. And so this is going to be implicit differentiation. So I'm going to go ahead and kind of I like to do d dx to each term. And we're going to notice that this third term, xy, this is going to be product rule. So we're going to get 2y dy dx equals, that's going to go away to 0. And this is going to give us 1 times y plus, and then x times 1 dy dx. All right, we didn't put dx here because we just don't have to. It's the same variable. So I'm going to move everything with the dy dx to the left side. So 2y dy dx minus x dy dx equals y. Then we can factor out a dy dx. And that gives us 2y minus x equals y. And then we can divide. We get dy dx equals y over 2y minus x. Okay, and so for this question, for the point breakdown, you basically got 1 point for this line, this kind of first line here, basically for the implicit part. So you got 1 point for having the dy dx's, but taking that derivative correctly, you would have needed to still do the product rule. And you got 1 point for kind of the final solution getting there. So that was worth 2 points. So if you got that right, you can put a 2 out of 2 or a 1 out of 2, 0 out of 2, whatever you got. Okay, B says find all points on the curve where the tangent line has a slope of 1/2. So kind of, x1, y1, and m, and we're knowing that the m is 1/2. So what we're going to do is we're going to, basically the m is dy dx. So what we can do is we can set 1/2 equal to y over 2y minus x. And basically, so we're just plugging in 1/2 where we saw the dy dx. Now we have an x and a y. That means we have 2 variables. So we need 2 equations. So the other equation on these are always the original. Y squared equals 2 plus xy. So that's 2 equations and 2 unknowns. Now I'm going to take the top one and I'm going to go ahead and cross multiply. And so that gives us 2y equals 2y minus x. And something nice happens on this one. We don't even have to use the second equation, because when we cross multiply, actually if we try to isolate for x and subtract 2y to both sides, we're going to get 0 equal to negative x. Divide by the -1, that's the same as just 0 being equal to x. So that's pretty nice there in that it kind of solved right there. We didn't have to plug in to the other equation twice. We are still going to want to plug into that other equation right now, but we didn't have to do it twice, which is kind of nice. So we got 0 is equal to x. And so now we're going to plug that 0 into our other equation to solve for y. So that's going to give us y squared equals 2 plus 0 times y is just 0. So y squared equals 2. take the square root of both sides. And this is implicit, so remember implicit, we always want plus or minus. So you would lose a point if you didn't have the plus or the minus. So you got to be careful. So this, we could have 1 as being square root of 2, and then we could have a second x1, y1, and m with 0, negative square root of 2, and 1/2. Now let's reread what they actually wanted us to box. Find all the points x, comma, y. So the points would be 0, comma, square root of 2, and 0, comma, negative square root of 2. Those would be our 2 points. So in this case, we got 1 point for this line up here where we set 1/2 equal to y over 2y minus x. That was worth 1 point. And then the second point was for the answer. And you needed both of them. If you didn't have the negative, you're not going to get that point. So again, you'll grade yourself out of 2. This would be a 2 out of 2 if you had all that work. Okay, C, show that there are no points on the curve where the line tangent to the curve is horizontal. So what we need to do on C is we need to basically say, okay, dy dx equals y over 2y minus x, and this is going to need to be equal to 0. Now, when that's equal to 0, what we're essentially doing is we're saying that means that y would have to be equal to 0. The top part would have to be equal to 0. So now we have our other equation, our original equation, the y squared equals 2 plus x times y. And if we plugged in 0 there, 0 squared equals 2 plus x times 0. That's going to go to 0. 0 equals 2, that's false. Right? Anytime you get something like that where 0 does not equal 2, that basically proves that that point doesn't exist on our graph. So that y equals 0 cannot coexist with that equation. So that's our proof. That's really all you have to say now. You could kind of just say, therefore, the curve has no horizontal tangent. So you got 1 point here for basically, setting the top, the y equal to 0. And then your second point would have been kind of for this explanation down here, showing that it's false. Something, the 0 can't be 2. So those are 2 points there. Okay. And then I'm going to get another page for us. So part D asked us to let x and y be functions of time t. This is kind of where we get into the implicit related rate stuff. Right now they're functions of time t, so it's a rate. And at time t equals 5, the value of y is 3, and dy dt equals 6. Find the value of dx dt at time 5. So I'm going to kind of go ahead and recognize, hey, this is a related rate. I like to kind of separate these. So we still have our original equation, y squared equals 2 plus xy, but now we're differentiating with dt, so that's important. And so our givens, they gave us, time was equal to 5. They gave us y was equal to 3. They gave us dy dt is equal to 6. And they want us to find dx dt. So we don't have any constants here. None of these are constants. So we're going to just take the derivative. So we're going to take the derivative kind of d dt, d dt, and d dt. And this is going to be a different derivative than we got before because it's with respect to time. So we get 2y dy dt equals basically 0 plus, now this time when we do the derivative first, it's going to be 1 dx dt, right? We have to differentiate with respect to time, so we do dx dt. Then y we leave alone. This is still product rule. Then x, then the derivative of y will be 1 dy dt. So that's our implicit with respect to time. Now we can start plugging in. 2 times y was 3, dy dt was 6, equals dx dt is what we want, so I'm going to kind of leave the dx dt there. And then times y was 3. Then plus now x we don't know. And then dy dt they gave us was 6. So we kind of need to figure out what is x, right? The two unknowns we have are dx dt, that's what we want, and x. So how can we solve for x? Well, we can solve for x back here. But the important thing was that we took the derivative first. Okay, we needed to take the derivative first. Now we can plug in and solve for x. So we're going to plug in the 3. 3 squared equals 2 plus x times 3. That's 9 equals 2 plus 3x. Subtract both sides by 2. Divide both sides by 3. 7/3 equals to x. So now we're going to put that 7/3 in this equation. And so now we can solve. 2 times 3 times 6. That is basically 6 times 6, so that's 36. Equals 3 dx dt. Plus, and then the 3 and the 6 can cancel, and 2 times 7 is 14. So we'll subtract 14, 24 equals 22, sorry. 22, it would have been nicer if they made it 14, 24. 22 equals 3 dx dt. Divide by 3, and we get 22/3 is equal to dx dt. And if we come back up just to double check on our units, they didn't give us any units, so we're not going to report any units. And that's kind of your rule of thumb, is always check units. And if they don't give you any, then you can't report them. But if they have feet per second, then you're going to report it with those units. So this was worth 3 points. The first point was for doing the kind of the implicit derivative. So if you had this derivative correctly up here, that was worth 1 point. And you need to have the dx dt, the dy dt, I mean, it needs to be totally correct. You also got 1 point for solving for x. So even if you did the derivative wrong, but you plugged in and solved for x, you got a point. And you got 1 point for the final answer. So this would have been out of 3 points. So go ahead and add up your score. Try to figure out what you got out of 9. This was a little bit of a trickier question, but I think everyone really should have gotten part A totally correct. Everyone, I think, should have gotten it 2. And hopefully, like I said, your goal would be to get a 6 or higher. But even, 4 points or so, you're on track right now. Okay, jumping ahead to the next one. This is a cone question. So almost all of the cone questions are the same with those similar triangles. That's something we want to be watching out for. And so as we read through this, they did give us a picture. They say that a container has the shape of an open circular cone. The height is 10 and the diameter is 10. Now immediately we want to kind of get rid of that diameter being 10 and change it to the radius being 5. Okay, all cone questions we want to have radius, not diameter. Same thing with cylinders. So that's something I'm going to just immediately do myself. Then water in the container is evaporating so that the depth h is changing at the rate of -0.3 centimeters per hour, and then they gave us the formula for the volume. So on A, it says, suppose you were asked to find the rate of change of the volume. So we want dV dt. When the depth is 5, they re-give, and they say explain why the formula could not be implicitly differentiated with respect to time in order to determine this rate. What would you have done in order to find this rate? So this is a little bit of a weird question, but they're not asking us to solve it. Instead, they're asking us to just kind of explain why we can't implicitly differentiate it right now. So we're not actually giving an answer right now, we're just explaining it. And so basically the reason why we cannot implicitly differentiate this is because of those two variables. We have an r squared and we have an h, so we have two variables. And so since we're just kind of doing the explanation, this is the whole similar triangles, so we're just explaining. So we would kind of say, and I might do a little of the work just to help me out. So the big R, 5 over little r, equals 10 over little h, and if we cross multiply we'd get 5h equals 10r. and they gave us, dH dt. So we would want to replace r. So if we divide by 10, we get 1/2 h equals r. So that's kind of what we're going to be plugging in. So we're going to say we cannot use v equals 1/3 pi r squared h to implicitly differentiate with respect to time. Basically because we do not know dr dt. Right? This would give a product rule with dr dt and with dH dt. So instead, we would need to use similar triangles. To find a ratio between h and r. And in this case, it's 1/2 h equals r to replace r. So that's kind of our explanation. I know it's a little bit of a weird question there, but that's how we would do that explanation there. So next up, for part B, find the rate of change of the volume in the water. So this is actually going to just be solving for that. So find the rate of change of the volume of the water with respect to the container. So I'm going to kind of put in my variables. So we know that they gave us, I'm going to get rid of the big R and the big H. We don't really need those. So we know that H is 5. And then we know that dH dt is -3/10. So the water level is decreasing because of the negative, so our dV dt really should be negative as well. So we have v equals 1/3 pi r squared h. And then we also had that 1/2 h, so we're going to just plug that in. So v equals 1/3 pi times 1/2 h squared times another h. This is going to give us v equals 1/3 pi times 1/4. We square the half and we square the h. And that'll give us 1/12 pi h cubed. So that's the formula that we want to differentiate. So now when we take the derivative, the 3 is going to come down and we're going to get 3/12, which is 1/4 pi h squared times dH dt. And then we're going to get dV dt equals 1/4 pi times 5 squared times -3/10. And this will give us 1/4 pi times 25 times -3/10. And so that ends up being -75/40 pi. Which we can go ahead and simplify. And I'm going to add another page in here. So we can divide both sides by 5. So if we divide both sides by 5, that'll give us -15/8 pi, and then we need our units. So our units here were in, looks like centimeters per hour, but it's a volume. So because it's a volume, we're going to put centimeters cubed per hour. Okay, and then our third one is asking us the surface area of the exposed water is changing by 9 pi centimeters squared per hour. When the depth of the water is 4 centimeters, at what rate is the radius of exposed water changing at that point in time. So this is a little bit weird, but the radius of exposed water, that's just the radius, okay? So it's like the small r. So they want dr dt. So they're giving us that the d surface area dt is 9 pi, and they're giving us that the depth is now 4. So they changed the depth on us. So C, they're going to put that the depth is 4. That means we don't know about dh dt anymore, okay? We don't know what dh dt is anymore. And then they're giving us the d surface area dt is, now it says the surface area of exposed water is changing at a rate of 9 pi centimeters squared per hour. And this is actually, I kind of changed, this problem got changed from what the AP test said. And I really should have specified if this was positive or negative. So, up here we see that they say when the container is evaporating, so that the depth is changing. So we knew that it was evaporating, so really this should have been negative 9 pi. But if you put positive 9 pi, because on a real AP test, they would have been a lot more clear with that number. If you put positive 9 pi, give yourself the point. Don't take off your point. Okay, so those are the two givens that we have. So we know that the area for the surface area for, now it's just the exposed water, right? The surface area of the exposed water. So exposed water, that's only this shape here. That's the surface area of exposed water. Nothing else is exposed. So that's actually just a circle. So that formula is just pi r squared. And so we didn't even need to have any sort of h in there at all. So what's going to happen is this is going to give us dA dt equals 2 pi r dr dt. Okay, and so initially you might be like, oh wait, we didn't even need the height, but we do need the height because when we start plugging in, we're going to get negative 9 pi equals 2 pi times radius, which we don't have, times dr dt. So we need this height of 4 to figure out what the radius is. And the way we're going to do that is we're going to just kind of come back up to our similar triangles where we have this 5 over r equals 10 over h, right? And we can actually plug in, down here to this line. So that 1/2 h was equal to r. So 1/2 times 4 is equal to r. So we get a radius of 2. So the pi's can cancel out. Negative 9 equals 4 dr dt. And then we have negative 9/4. We need our units. So our units are going to be centimeters per hour equals dr dt. So kind of the points breakdown on this one, I forgot to start at the beginning. The first one was worth basically just it was worth 2 points. So it was worth 2 points. So the 2 points were saying, basically mentioning that we have something with two variables or we don't have dr dt, something like that would be 1 point. And then talking about the similar triangles, this ratio, if you had the number, the 1/2 h, whatever, that was worth 1 point. So this guy was out of 2. This next one was a lot. This next one was out of 5. So this next one, you got 1 point for somewhere plugging in the 1/2 h. That was worth 1 point. Okay, we're talking about the r equals 1/2 h. Doing that was 1 point. Then getting v to this line, that was worth a 2nd point. Okay, then solving right here and getting this guy right here, this was worth 2 points. And then you needed to have this proper dH dt. Now, if you instead solve for this totally correctly using product rule, and you figured out what dr dt was from this equation, that is possible. You could get those points as well. And then the last point would have been for our answer, and this point needs to have the correct units. So you need everything, the negative 15 over 8 pi centimeters cubed per hour. So again, if you got to that answer doing it with product rule, doing it a little differently, you would have gotten the 5 points. But this last step does need to have the right units. So this guy was out of 5 points. Then the last one was 2 points. So this last one was 2 points, 1 point. That should have been an R. Yeah, 1 point for taking this derivative correctly. And you got 1 point for the final answer. So this guy was out of 2 points. So again, grade yourself out of 9. This was kind of tricky, but if we practiced this, we should have been able to do pretty well on that. Do be careful about your units and make sure that we're paying attention to those. So last question is this lighthouse question. This one's kind of tricky. I thought it was definitely a little bit of a more difficult question. So we have 2 ships and we have a lighthouse. And so it tells us that ship A is traveling west and ship B is traveling north. And so that kind of helps us to, if we draw in, to realize that, okay, dx dt is going to be negative and dy dt is going to be positive, right? Because this distance here, y is getting bigger, whereas this distance here, x, is getting smaller. So that's important. So when we kind of do for A, right? Actually, A doesn't have that. A is actually just Pythagorean theorem. But when we get to B and we plug those values in, we need to make sure we're paying attention to what's negative and what's positive. So, using basically a squared plus b squared equals c squared for A, because they just want to know the distance between the ships when x is 4 and y equals 3. So, we can call A x squared and b y squared equals c squared. So that's going to give us 4 squared plus 3 squared equals c squared. And if you want to just jump to 5, you can. Right? If you remember those special right triangles, you can. Now, don't just put 5 equals c. It's important to put 5 kilometers equals c. This is only worth 1 point on this question, and you're going to lose that point if you don't have your kilometers. So be very careful about that. Okay, part B then asked us to find the rate of change in kilometers per hour between those 2 ships. So on B, this is where I like to kind of set up my three sides. And so I'm going to say we know x is 4, we know y is 3, and then ship A is traveling at a speed of 15 kilometers per hour. So that's dx dt, but it's going to be negative 15 because it's getting smaller. And then dy dt, that's going to be positive 10 because it's getting bigger. And if you mixed up your negative and your positive, you would still be able to get 3 out of 4 points on this. So we're going to start off with this, basically x squared plus y squared equals c squared. If you used a squared and b squared, that's fine. I'm going to use x and y because those are the variables in the picture. So we take the derivative, we get 2x dx dt plus 2y dy dt equals 2c dc dt. And this was a really, really pretty easy question to get a bunch of points on because they gave you 1 point for the equation here, and they gave you 2 points for this derivative. Now, you could not get 2 points if you don't have the dx dt, dy dt, dc dt. You would lose all those points. And so now, just plugging in, right, 2 times negative 15, 2 times 4 times negative 15, plus 2 times 3 times 10 equals 2. Then we're going to use our answer from part 1 times 5 times dc dt. So this is going to give us negative 120 plus 60 equals 10 dc dt. That's negative 60 divided by 10, right? So negative 6, and we need our units, which are going to be the same kilometers per hour that we had for the other 2 speeds. So this answer of negative 6 kilometers per hour, that's your 4th point. And again, you really do need those units there. So this was, the first one was just 1 out of 1, and this would have been out of 4. Okay, and then our last question, C, is talking about our angle. And these ones are a little bit trickier, but the more you do, the better you'll get at them. And so let theta be the angle shown in the figure. So they give us this angle right here. And we want to find the rate of change of theta, so d theta dt, when x is 4 and y is 3. So I'm going to kind of jump down and give ourselves a little bit more room here. So looking at the picture, right, we know, basically now we know dx dt, dy dt, and we know dc dt because we just solved for that. So we could actually do sine, cosine, or tangent. And the answer key uses tangent because we were given, y and x, but I don't like to use tangent. If you use tangent and you get to the right answer, you're going to be fine. The reason I don't like to use tangent is the derivative of tangent is secant squared, and that's a little bit tougher. So I'll show you guys the official AP answer key in a second, but for me, I would have preferred to use sine or cosine because they're just easier. So as long as you get to the right answer on this, I'll kind of talk about that, you're going to be fine. So I'm going to use sine because to me, sine is the easiest derivative. And even though they gave me dy dt and dx dt, we solved for dc dt. So we actually have all of them. So when we're picking between SOHCAHTOA and TOA, normally we're going to pick the two that we're given. And in this case, the two that were given were for TOA. But because we just solved for the hypotenuse, we can actually use any of them. So I'm going to go ahead and use sine. So my givens are that x equals 4, y equals 3, dx dt equals negative 15, and dy dt equals 10. So that's why I said, you would pick tangent because those are opposites and adjacents. But we solved for c, and we solved for dc dt. So I can pick any one that I want. So I'm going to pick sine. So sine of theta equals opposite over hypotenuse. So in this case, sine of theta equals y over c. Now we do need to put y over c. And this is what made this question harder. We cannot plug in c as 5, and we cannot plug in y as 3. And the reason we can't plug any of those in is that they're all changing. Okay, ship A is changing, ship B is changing, so the C is changing as well. So all three of those are changing, and this makes this question a little bit tougher than normal. So we're going to take the derivative of both sides. Derivative of sine is cosine of theta, and times d theta dt. And then that's going to be equal to, now we're going to have to do quotient rule. So low, d high is going to be dy dt. Minus high, d low is going to be dc dt. All over low squared. Oops, c squared. Okay, now for cosine of theta, well, cosine of theta is adjacent over hypotenuse. So that's going to be equal to, the adjacent side is x. And this is where, we are plugging this in because we're not taking the derivative. We're just trying to get a value. So x is 4 over hypotenuse is 5. So this is where we're starting to plug everything in. So 4/5 for cosine theta, d theta dt, equals for c, we're going to plug in 5, dy dt, we're going to plug in 10, minus y, we're going to plug in 3, dc dt was 5, all over, and then, dc dt was negative 6, that's my fault, dc dt, negative 6, all over 5 squared. So this is going to give us 4/5 times d theta dt equals, this is 50, and then plus 18, so that's 68 over 25. We're going to multiply both sides by 5/4 to isolate for d theta dt. So this cancels out to a 5, and then 68 divided by 4, we're going to get a fraction. And so we can divide both sides by 2, that'll be 39, and that'll be 2. And so we're going to get d theta dt equals 39 over 10 radians per hour. And actually I made a small mistake here. So 68 divided by 2 is 34. I don't know what I was doing. Right, they're both even. 6 divided by 2 is 3, 8 divided by 2 is 4. So this is 34 over 10. And so that can actually simplify once more. If you put 34 over 10, you'll get it right, but you can divide those each by 2. So 17 over 5 radians per hour. So the units for theta, this is just something you have to memorize. The units for theta are always radians. And then the time in this case was per hour. So this was another 4-point question. And this one, you got the first point for having any expression that had theta and, the variables. So sine of theta equals y over c, you would have gotten a point. Now, alternatively, you could have used tangent of theta equals, and that would have been y over x. That would have gotten the point. Or you could have even used cosine of theta equals, and then you would have had x over c. So either of those would have also gotten the same point that I had up there. Then the second point was differentiating, and you needed to use it was 2 points. Basically, you got 1 point for the left side, and then you got 1 point for the right side. And you needed to use the quotient rule and the chain rule. So like the implicit for the chain rule is what I mean. So you needed to have the implicit parts and the quotient part. So that was worth 1 point. And then the last point would be getting to this answer. So the AP, I'm going to pull in the AP scoring key and just show that how they kind of did this with tangent. So they used tangent theta instead. And so then they would have had secant squared theta, d theta dt equals, and they did the whole low d high minus high d low. And then at x equals 4 and y equals 3, so cosine, right? Cosine would have been, the x would have been 4 over 5. And so secant, they flipped that to 5 over 4. And so then they plugged that in for secant squared, and then they solved, they got to the same 17 over 5. So if you did it that way, you would have gotten the 5 points as well. So go ahead and grade yourself, right? You're going to grade yourself out of 9. So again, this one was worth 4 points. So out of 9, kind of figure out your grade. And then try to add up all 3 of your grades. So this would have been total out of 27. And honestly, if you got anywhere, 15 or higher, that's really, really good for homework and for practicing on these. So 15 or higher, that's awesome. Especially 18, 20 or higher, like really, really awesome. And even if you got more in like the 8, 9, 10 range, that's at least, you've got some stuff, and you're just going to want to review these and practice them a little bit harder. Okay? So we are going to have a quiz coming up in the next couple of days that this will be really good problems to review and study these. Maybe, try to cover them up and do them blank, and then go through the answers again one more time.